topics like filter, IIR filter, and two structure we have seen, that is direct from 1 and direct from 2. Okay. So direct from 1, just I am revising it. Direct from 1 is here you can see that in direct from 1 the input parts, okay, and output parts are separated, and sum of the input parts is called another variable, that is wn, and output part is yn is delayed and it is added with that input part wn, then we get the output. This is the direct from 1. In direct from 2, and all of you do this exercise. Okay, I have told you in the last class, but none of you have shown. Okay, do this problem. Okay, second order digital filter. Then in direct from 2, what we do? We represent the transfer function az, that is yz by xz, and we split it into two parts. Okay, so and we take some intermediate stage wz. Okay, why? So two stages are there. One stage output goes to the input to the another stage. So in the first stage, input is xz, output is wz, and in the next stage, input is wz and output is yz. So you have to represent the transfer function in this way. So if you have this kind of transfer function, okay, so one part it will be called, say we separate the numerator and denominator. This is numerator and this is denominator. So 1 by denominator represents one stage, that is wz by xz, and another stage it represents the numerator. So like this, wz by xz, okay, represents numerator, 1 by denominator, 1 by this denominator, and yz by wz represents the numerator. Okay. So coefficient bk and ak are there. Now if you write wz in terms of xz and delayed version of wz, and yz in terms of delayed version of wz, then we calculate, we get this structure. Okay. So the beauty of the structure is that we use only delay variables, that is halved. Delay variables or delay stage z inverse becomes halved. Okay. Comparing to the implementation using direct from 1. So delay stage is halved, but number of addition stages remain same. Okay. So you can see that this was the previous stage, okay, where in each stage delay separately was there. Now only one delay is there, delay stage, this case. Another important thing is look into the coefficient. Okay, so here all coefficients are positive, b0, b1, b2 up to this bm. Okay, all are positive. All are positive, and in this side, left hand side, the coefficient a1, a2 all are negative. Okay, So this can be correlated with the transfer function. Okay. Your transfer function is this B0 Z inverse Z0, that means 1 B0 plus B1 Z inverse plus B2 Z to the power minus 2 plus B3 Z to the power minus 3. These are all present in numerator. Okay. So, and you can see that YZ, this is YZ in the numerator, and the coefficient B, all B's are taken as positive in this side, because both y it belongs to the, you can memorize in this way that if it is at the output side, that is yn side, the coefficients are positive. Okay. But if the coefficients are a negative side, that is coefficient a, that is it goes to the xz side, input side. So that time the coefficients are taken as negative coefficients. Okay. So this thing you need to remember. Then you can, from any transfer function, you can directly implement this structure. So no need to draw it in detail. Okay, just you have to keep it in mind that the coefficients b, which goes to the output side yn, all are taken as positive. That means its sign will not change. Okay, its sign will not change. And if the coefficient, that is a, goes to input side and their sign is changed, okay, their sign is changed. So you can see here in the coefficients, that is a, all are positive here, or this thing. Now we take the opposite sign in the input side, that is minus a and minus a to minus a. Okay. So this thing you need to keep in mind. And just 1 minute, I am coming, some call is coming. To the coefficients, okay, you need not calculate all this detail if it is not asked. So directly you can draw the structure as, so b0 is here, y at the y side it is b coefficients. So b0 is 1 and b1 is r cos omega 0, okay, minus r cos omega 0. And the coefficient xz, okay, the coefficient xz is a, all a's. So it is 1, then this one a1 is minus 2r, okay, a2 is r square. So this, note down the coefficient. A1 is 2r cos omega 0, okay, like this way. Here it is 1, okay, a0 is 1, so it is not required in the case of input. So it is 1 always, then goes directly to this side, but direction is this. But for all other coefficient, direction is towards x. So a1, a2, all will be minus. So a1 is 2r cos omega 0 and a2 is r square. Okay. So this way, if you remember it, then you can see that the right hand side, thus coefficients go towards while it is 1. Okay, not written here. It is no gain, means it is 1, no change in the coefficient. So it is 1. Then a1, this is b0 is 1 and b1 is minus r cos omega 0. So simply it is written as minus r cos omega 0. Then the second term z to the power minus 2 term is not there, so it will be absent there from there. And in the input side, this first coefficient is wn. It is wrongly, it is actually wn here, intermediate stage. It is, it is coming from this analysis, but this gain is 1, okay, goes to this direction, but this coefficient goes to the input side. Okay, so a1 is how much? A1 is 2r cos omega 0, so it will be minus of a1, so it is plus 2r cos omega 0. A2 is minus, A2 is r square, so it will be minus of A2, that is minus r square. So each time this Wn stage is delayed and it is multiplied with coefficients and it is added with the next stage and then goes to the, it is added with the next delay element output and goes to the next stage. Okay, this one, and similarly this is added. So is it clear?
Yes, sir.
Okay. So now we proceed to, this was all discussed, but those who are not uh, paying attention, for them I am again revising, uh, I repeated it. So now we go to the next topic, that is cascade form realization. Cascade form realization means there are many states, H1, H2, HKZ. Any transfer function can be written in terms of product of some internal states. Okay, so product of some internal transfer functions of some internal states. So like HZ, okay, it is coming with this type of product. Okay, so let us say we separated HZ in this way, that it is the product of two states H1Z and H2Z, where H1Z is having transfer function in this form. Okay, bk0 bk1 z inverse plus bk2 z to the power minus 2 and divided by 1 plus ak1 z to the power minus 2 plus ak2 z to the power minus 2, and h2z is this one, bm0 bm1 bm2, and divided by 1 am1 am2 with the term z with different powers. Okay. Now, first, any transfer function, the basic concept is any transfer function, it is not necessary that it will be coming with in this form itself. Okay, you have to represent, okay, any transfer function in this form only, where it can be written as product of two different transfer function. Okay, product 2 or 3, okay, the products of different transfer function, and each transfer function will be represented in the form of direct form 2, okay, that we have studied in the last topic. So each transfer function further will be represented in terms of direct form 2. So we consider this one, H1Z and H2Z as this one. So individually they are written as transfer function. So here we write that it is bk0 bk1 z inverse z to the power minus 2 and 1 plus ak1 z inverse plus ak2 z to the power minus 2. So this transfer function, particularly h1z, it is given written as this. So you can see the right hand side here also, if this is the main structure. Okay, so at the middle you have to use some delay element z inverse, then another delay element z inverse, because it goes up to z to the power minus 2. Okay, these two terms will be up to this stage, it will be there. And then what you have to do, that after each stage, each delay element, you have to pass it through the coefficient, okay, either to the output side or to the input side. If it is to the output side, then the coefficients are bk0, bk1, bk2. No change in their polarity sign. And once you pass this through this coefficient stage, then you have to use the adder. Here one adder, here one adder. Then to the for the input side is always start with 1 plus. So this one is this one. This is direction is towards output, so it is positive. But this direction is towards negative. Okay, so the coefficient sign will change. Okay, AK1 will go to this side, AK2 will go to this side, to the input side. Okay, so its sign will change, and each time they will be added. Okay, and now output of this stage y1n, say first stage, goes to the input to the next stage. So for the next stage, the similar way it is done, the stage H to Z, it is done. Okay, provided the coefficients, okay, that goes to the output side having will have no change in the sign. Okay, whereas it goes to the input side, sign is changed, that is minus AM1 minus AM2, like this. So this is the parallel structure, a cascade structure. So different stages are connected in series. Okay, now we see one example. So what is the example? That yn is equal to 3 by 4 yn minus 1 minus 1 by 8 yn minus 2 plus xn plus 1 by 3 xn minus 1. Okay. So can anybody tell, is it IIR system or FIR system? Please respond.
Sir, FIR.
Anybody else? Who can tell it is not FIR? If it is not FIR, why it is not FIR? Can anybody tell? Output is fed back. That means it is recursive. There are different delays in the output, yn minus 1, yn minus 2. Okay. So this is recursive. So recursive system means what? FIR or IIR?
IIR.
Yes. So earlier we have discussed this thing, but I don't know why you could not tell. Not you, all of you. I am telling out all of you. All of you are sitting and seeing and doing nothing. So if there is delay element in the output, then it is obviously IIR system. Past inputs and present, if it is only consisting of past and present input, then it is called FIR. If only xn minus 1 is there, then it is only FIR. Okay, that means only zeros term, only numerator will be there, no denominator. But in case of IIR, both numerator and denominator in the transfer function will be there. These things you have to keep in mind. Okay, very important concept. In the transfer function hz, both numerator and denominator will be present in case of IIR. But in case of FIR, only numerator term will be present, because it depends only on xn, previous values of input, not previous values of output. Or delay output delay is not considered, it is not recursive. Okay. Now coming to this problem, this is transfer function given 3 by 4, no, this is series. The difference equation is given, yn difference equation. Now you have to convert into transfer function. How will convert this transfer function? Can anybody tell?
Sir, we are taking the coefficient of x and x power n, no, x of n in the numerator, and there is xn minus 1. So we wrote z minus 1. And similarly, in denominator, we will have 1 minus the coefficients of y in minus sign. So there 3 by 4 is positive. So we have minus 3 by 4. N minus 1 is there, so z power minus 1. Plus similarly, minus 1 by 8 is there. So minus of minus plus 1 by 8. And n minus 2 is there. So z power minus 2.
So simply could have told that if you take Z transform, okay, अगर Z transform ले लेते हैं पूरा equation का, and in that case it will be coming in the of the with the terms of yz and xz and multiplied with z inverse or z to the power minus 2 power of z terms. So you take common yz into one side, xz into another side, okay, then you calculate yz by xz. Actually it is not shown directly there. Okay, those who are brilliant, intelligent, then they can easily understand it, that how yz and a by xz is calculated. Take the z transform, then all term will come under the brackets of multiplied with yz and xz. Okay, then take the ratio yz by xz. So with this, then for this cascade implementation, this function, okay, this function should be splitted, okay, splitted into separate transfer functions. Okay, so one transfer function, say two transfer function we take because power of z goes to 2 only, minus 2. So we take two transfer function h1z into h2z. Then implement this h1z and h2z separately. So how it is done? Using direct form 2. Okay. So h1z we are assuming as, okay, h1z we are assuming as the first ratio, that is 1 plus 1 by 3 z inverse divided by 1 minus half z inverse. And h2z, can anybody tell what h2z is assumed? h2z कितना है?
Sir, 1 by 1 minus 1 by 4 z inverse.
Yes, correct. So now once you separated out h1 two transfer function, then individually you implement using direct form 2. So in case of h1z, your transfer function is 1 plus 1 by 3 z inverse divided by 1 minus half z inverse. So it is the coefficients going towards output side, that is if you assume that it is yz by xz. So the ऊपर में जो है numerator में जो coefficients है that goes to the output side where its sign will not change. So this stage we are considering the first stage in the circuit diagram h1z. Okay, so first coefficient is 1, so 1 is not written here, so it is 1. So 1, and the coefficient goes to the output side is 1 by 3. That part is over. Then the coefficients goes to the input side. Okay, first this is going directly there, arrow is going to right side to the outwards output side, it is 1. Okay, so let me write here, then it will be clear to you. This is 1, and this is also 1. Okay, and similarly this is also 1. So 1 by 3 and 1 minus of minus 1 by 2. So it is 1 by 2. Then H1Z is over. H2Z is how much? 1 by 1 minus 1 by 4. So in this stage, okay, in this stage, if you use direct form to realization, so there is no coefficients or only one coefficient is there, that is actually 1. Okay, this one is here. This one is here, and I have not drawn the arrow over there. So this one is 1 here. Okay, and Z inverse is not there in the numerator of H2Z. So that's why no delay, further delay is considered. Okay, here. So it is 0 and nothing, it is loop is stopped. Okay, this loop is stopped here. And in the input side, we have to use is the coefficient. So here coefficient is 1 and minus 1 by 4. So minus of minus 1 by 4. So it is plus 1 by 4. So this way you can remember. Or otherwise, if you don't understand this concept, you have to go to the for writing the detailed procedures. Okay, that is done here. Detailed procedure is given in this slide. How to calculate. So in that case, you have to again revert back to the time domain sequence. Okay, you see that yn in terms of wn minus 1, wn xn. Then you have to revert back into the time domain sequence. Then you will be able to design the structure. And the same design structure can directly be obtained from seeing the transfer function and knowing the rules. If you know the rules, then you can directly draw the structure. Okay. So have you understand the rules? Have you understood the rules?
Yes, sir.
Okay. So all others should say yes. What about others? Raise your hand. All of you, please raise your hand. Okay, many hands I have seen. That means I assume that you are understanding. Okay. Becomes very difficult for the teachers in this situation to understand the mind of the student, because these are not visible. You are not, your face is not visible, your presence is not there. It becomes very difficult for a teacher. Okay, so now then we go to the other design, that is parallel form. Okay, parallel form. Up to this topic I will tell today. Then and these are very easy, and I hope you will study it by today only, so that we can start the new topic from tomorrow. Okay, after this, many structures are there, so those things we have to understand. Okay. Then you see that parallel form. So we have studied the cascade form. Okay, that's those individual states. Individual states are connected in series. Now, what happens if the individual states are assumed to be connected in parallel? Okay, that means one input is common, okay, to all the stages. Input is common to all the stages, whereas in cascade form, input is not common to all the stages. Okay, input is different for different stages. In parallel form, input is common to all the stage. So this thing you can see, this is the parallel form structure. Okay. So you see that input xn is connected to all the stages with some coefficients added, with some constant. Why this constant? I will tell, you will understand when we go through the discussion, okay, later on. Now, and individual outputs are added. Individual outputs from all the stages are added. Okay. So these two output is added with adder. Okay. Then output of this adder is taken and this is also added with the next stage. So each time, okay, output is added with the output of the previous stage. So all outputs are added. Now, what is the basic concept? That a parallel form realization of an IIR system can be obtained by performing a partial fraction of, okay, so any transfer function you need to represent in partial fraction. Okay, so what do you mean by partial fraction? That you have to divide a numerator with denominators, okay, and then perform the and calculate the coefficients. Okay. So, in those individual fraction, there will be poles. Okay, that we have seen earlier when we studied the partial fraction expansion method. So Hz, this Hz is actually sum of this some coefficient C plus C1 by 1 minus P1 Z inverse plus C2 by 1 minus P2 Z inverse plus Cn divided by 1 minus Pn Z inverse. So that is the poles are P and with their coefficient C, C1, C2, etc. Now if you write that individually they are all forming a separate transfer function. So this C1 by 1 minus P1 Z inverse forms one transfer function H1Z. H2Z forms one transfer function, that is C2 by 1 minus P2Z inverse. So up to the nth stage. Now what is the output? YZ is C into, multiply this with xz, take xz into the right hand side, okay, then you add. So this is the term that we mean, that is meant by this expression. This is the diagram. Okay, this is the diagram. Now let us do one numerical, okay, regarding this, that yn is equal to minus zero point 0.1, okay, into yn minus 1 minus zero point 0.1 into yn minus 1 plus 0.72 yn minus 2 plus 0.7 xn minus 2.52 xn minus 2, realize in parallel form. Okay. So this is the calculations. That's the slide I have given to the previous batch student. So he has solved, okay, some steps. Okay, you can see that Z inverse. So this is your expression. Now how we will find the transfer function? So YZ, take the Z transform. Now what I discussed, then you can how to calculate the transfer function. So first you take the Z transform. So it becomes YZ is equal to minus 0.1 into Z inverse YZ plus 0.72 Z to the power minus 2YZ plus 0.7 xn is there, so its Z transform is xz, and 0.252 xn minus 1 xn minus 1, so it is 0.252 into Z inverse xz, that is not coming here. Then you take the ratio yz by xz, okay, so it is coming 0.7, this is 0.7 uh, yz, then take the commons yz and xz separately, then you will get divide those two terms, yz by xz. So you will get this expression. Now you divide this, since this order of the two polynomial numerator and denominator are same. So first you have to do the division method, long series division. Okay. So there you will see this way they has done that you have to first you remove the higher order terms. Okay, 0.72. Remove the higher order terms. 0.72 z square plus 0.1 z inverse plus 1. So if you multiply with this with 0.35, so it will become 0.252, will cancel out. So this will be coming in this form. Okay, after long division, it will be coming in this form. So some coefficient is coming there, that constant c. Now the expression is coming in the form of ratio of rational function, that is, or where the order of numerator is lower than the order of denominator. Okay, so z inverse in the numerator and maximum order power of z in the denominator, it is -2. Okay, so now once you get this expression, now apply partial fraction method. So they have applied partial fraction method and they have calculated the value of a and b. Okay, this way, a and b. So your final expression is coming to be yz by xz as this one, 0.35 to 0.205, 0.206 by 1 plus 0.9 z inverse plus 0.1441 minus 0.8 z inverse. Okay, so that means this is similar to this kind of expression, okay, theoretical expression. Okay, so now according to the structure, a constant c is there and individual states. Okay, individual stage h1z and h2z, they are added. Now how the individual states are calculated, then it is coming from my slide, that individual stage. Okay, actually this is the partial fractions how they are calculated, or you can do like this. Okay, so individual state h1z and h2z. So h1z is represented as, again you use the direct from one rule. Okay, that, or you can simply write that if it is goes to the input side, then its coefficient is becomes negative, zero point 0.9 becomes minus 0.9. Okay, and minus 0.8 becomes plus 0.8. So this is h1z and this is h2z. Okay, this is whole h1z and this is whole h2z. So just go through these rules, just go through these steps, and you will be able to implement transfer function in parallel form. So how many the different, so we have studied different way of implementing IIR filter structure, that is direct from 1, direct from 2. Then what we have studied, uh, parallel cascade realization, then parallel realization. Okay. So another two are remaining, that is ladder and lattice structures, ladder and lattice, and also FIR implementation is remaining. So I hope you will understand clearly. Okay, up to this topic you should go through it. Okay, all the explanation is given.